Well, I'd like to start things off and thank you for taking the time to attend today's presentation. My name is Lance Zurich, and I'm the product manager for the Fischertechnik Education Division over here at Studica. And today I'm going to provide you with an overview of Fischertechnik's line of pre-assembled industrial simulation and training models. There we go. Now, whether you're an educator at the high school level involved in CTE training, if you're a college professor or an industrial trainer teaching programming skills required in manufacturing, maybe you're a company looking for ways to demonstrate your software-based solutions, or even just someone who's looking for ways to make IoT-related concepts easier to understand to employees or customers. In any case, I believe this presentation will offer some important options for you to consider. We're going to start off by considering the skills gap. Now, if you've attended any of our other Fischertechnik education webinars, you've probably heard me discuss the importance of STEM education. STEM, of course, is the acronym that stands for Science, Technology, Engineering, and Mathematics, and it should really go without saying that STEM education has been perhaps the most discussed topic in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is really in large part to help us best prepare them to take their place in the modern workforce. Not so long ago, when our parents or our grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. Now, as it ties in directly with the solutions that we're going to be taking a look at in this presentation, let's stop and consider that last skill area I just touched upon, that of being a PLC programmer. Now, first off, for anyone who may not be familiar, let me explain exactly what a PLC is. The term PLC is again an acronym, the letters in this case of which stand for Programmable Logic Controller. And essentially a programmable logic controller, or PLC, is a very specialized computer used to control the types of machines and automated processes which are typically found in an industrial setting, such as, for example, an automated manufacturing plant. As the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. Well, to get an idea of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, "The average PLC programmer salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year." End quote. And as I prepared this webinar, I took a look at the list of current job openings for PLC programmers on Nuvu, and this was back on February 27th, 2020, just before we got into the lockdown period. Now, the listings of that time showed 15 positions being advertised with salaries of over $75,000, and 2 of which listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level, but at the same time as this workforce of tomorrow is working on getting their training, more and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools offering programs just like this. So how long does it take to learn PLC programming? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. Of course, to become truly proficient in all 5 of the most widely used PLC programming languages, which you see listed on the screen now, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more time and more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are, of course, many other options available. High school CTE, career and technical education programs. There's, of course, adult continuing ed programs, vocational training, technical training and trade school, and as I mentioned before, employer-sponsored incumbent worker training programs. Now, that all being said, the question that still arises for the educator, and that's whether you're in the university or the vocational school classroom, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it realistic and hands-on? But there are also other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be a company involved in creating or marketing a new type of software-based solution that's looking for ways to make more tangible processes, which might otherwise be perceived as too abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer looking for ways to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's a company looking for an engaging way to demonstrate their services or solutions in a public setting such as trade show. Now, in each of these cases, and of course there are more, there is a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated processes. And that brings us to the line of fischertechnik industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate in both appearance and function various automated robotic machines and systems which are commonly found in commercial manufacturing. So this might beg the question, what is fischertechnik? So before we look at each of these models, let me just provide you with a real brief background of what fischertechnik is all about. Fischertechnik has been creating tools for teaching students of all ages about how technology works for over 50 years, all based around their unique building system. Now, what makes the fischertechnik building system unique is that unlike other popular construction systems where the components are designed to simply stack, in the fischertechnik system, it was created with more of an engineering mindset. The core building block in the system is designed to enable attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts available will also help to address very specific design needs. The fischertechnik system, I should say, was created back in the 1960s by German inventor Artur Fischer, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, had amassed more patents in his name than Thomas Alva Edison had during his own lifetime. Now, besides fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, and this was back in 1949, as well as being the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction. And they also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik sets, whether it's those intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology and how things work. Many of the products offered by fischertechnik for the education sector are subject-specific sets focusing on different STEM-related areas such as things like mechanics, pneumatics, robotics, or renewable energy. In many of these sets, students are asked to build a progression of models using the unique fischertechnik building system, and then perform various experiments which will then allow them to explore and understand these different aspects of the subject. There are also sets that are designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based programs, students dive deep into engineering and learning all aspects of the design process. And this requires them to work in small groups to create various devices and automated machines to meet the criteria being put forth in a series of real-world scenarios during the course of the curriculum, And of course, the students are going to have to do a lot of trial and error experimentation and research and so on. So it's very useful for developing the skills that are required for that. Now, the line of fischertechnik simulation solutions, which of course are the focus of today's presentation, are something much different. The line consists not of kits, but of a series of pre-assembled, small-scale models which replicate in appearance and function various automated robotic machines and systems. Models in the fischertechnik simulation line include things like conveyor belts, punching machines, 3-axis pick-and-play robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. This model consists of 4 individual workstations, in this case, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with oven, and a sorting line with color detection, all designed to work together as one self-contained material cycle. Now, before we begin to look at the models in the simulation line in more detail, let me very briefly outline some of the advantages of using fischertechnik solutions. I will apologize in advance, as the first few points are things I've already touched upon, but in each case, I think it's worth repeating. First, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this could be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, again, in both appearance and in function, common automated systems, things such as conveyor belts, sorting machines, robotic arms, and more. Because the models are compact and in most cases tabletop sized, they are not only ideal for use in the classroom or in office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. Next, quality. Each fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each of these models is available in a 24-volt version designed specifically for use with industry-standard PLCs. Now, it doesn't matter if you prefer Allen Bradley controllers, Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or countless others, you can control these 24-volt versions with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language, as you see listed on the screen. Please note, though, that with these 24-volt versions, no PLC is included, and all programming and programming guidance, as well as any power sources, wiring, and other hardware, are the responsibility of the end user. Of course, this should not be an issue, as these models are designed specifically for industrial users or for those who are teaching or exploring industrial processes involving PLC programming. In addition, though, for non-industrial users and for those educators who are not versed in or familiar with PLC programming, there are also several models which are available in 9-volt variations. These 9-volt versions ship pre-wired to fischertechnik's own proprietary robotic controllers. In this case, that's the Robotics TXT controller. And each of these controllers is pre-programmed using fischertechnik's own RoboPro graphic programming software. In the cases of these 9-volt models, the only additional component required is the addition of one or more 120-volt power adapters, which are sold separately. And we'll specify this as we discuss each of the models. Otherwise, in most cases, these 9-volt models are pretty much ready to use out of the box. Now, if you're involved in demonstrating or exploring IoT, which of course is also known as the Internet of Things, besides the fact that many end users have adapted many of the models in the primary line of simulation and training solutions for IoT purposes, in addition to this, fischertechnik also offers a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud control and what is sometimes referred to as Factory 4.0. In this case, the model is designed to be both controlled and monitored from a special web-based dashboard. And of course, we're going to discuss this in more detail a little later in the presentation. Finally, Fischer-Technik simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you probably noticed that the entry point for many of these products can easily be $20,000 to $30,000 or even a lot more. Fischer-Technik simulation solutions, on the other hand, are available at just a fraction of that price, as well as, again, being compact, realistic, and high-quality learning and demonstration tools. So on that note, as soon as I take a little sip of tea over here, we're going to get started on our overview of the models. The first thing we're going to look at is the vacuum gripper robot. Now, as you're going to see in this video, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position work pieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component you see in the video, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds. The 24-volt versions of this model, as well as all of the first five 24-volt models we're going to be looking at today, each have a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as with all 24-volt versions, will require you to provide the PLC and the program. And for a limited time, there is a 9-volt version available, which is the version you see in this video, which once again will come pre-wired to the Fischer-Technik Robotics TXT controller, and which will ship fully programmed using RoboPro graphic programming software. Now, if you wish to create your own programming, individual licenses of RoboPro are available on our website. Otherwise, for this 9-volt version, only the addition of a single 120-volt power adapter will be required. I will mention that for this and for all the other models we're going to look at today, the specs are also detailed in the product listings found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. Next up, we are going to look at the automated high bay warehouse. The model we're going to see here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, and 9 individual storage spots. Components on this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along again with carrier trays for each. I will mention that this particular model is a favorite among educators I've spoken with who teach programming because it gives you a lot to work with. And this is in regards to the movement of the picker mechanism, as well as the precision required to properly program it to store and retrieve each piece, each step which of course requires its own very specific coding. To get to the dimensions for this model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal in both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide your own PLC and programming. And for a limited time, a 9-volt version is also available, which is pre-wired again to the pre-programmed TXT controller, and one 120-volt power adapter is required for that. Next up, as you see, is the multi-processing station with oven simulation. The model we're going to see here features a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of around 11 pounds. Again, the standard version of this model is a 24-volt version for use with the PLC of your choice, with once again, a relay board for motor polarity reversal, and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And again, the limited edition 9-volt version in this case will require 2 robotics TXT controllers, so 2 120-volt power adapters will be required for all operation. And there we go. The next model we're going to look at, as you see here, is the sorting line with color detection. This simulation features a system for detecting work pieces of different colors and sorts them via a conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as with the models we've looked at before, the standard 24-volt version has a relay board for motor polarity reversal, and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, you will need to provide the PLC and the program. And there, for a limited time, we also have a 9-volt version of this one available. And again, it comes pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is required for that. And there we go. The next model we're looking at is the factory simulation. And again, this combines the 4 models we've just reviewed: the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with oven, and the sorting line with color detection, all combined into one self-contained material cycle. The cycle you're going to see works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with oven. After the work piece has been processed by this machine, it is then sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've already discussed the components of each of these models previously, I'm not going to belabor it by restating them here. But what I do want to discuss are the dimensions of this model as a whole. As it again combines 4 individual models into one cycle, it has a much larger footprint of approximately 39 by 31 by 16 inches, and it has a weight of between 43 and 46 pounds, depending on whether we're talking about the 24-volt version or the limited edition 9-volt version. Now, due to these dimensions, please note that this model will only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models tend to be in high demand, please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. A few other things to note. First, again, this is currently available in the standard 24-volt version and in very limited quantities in the 9-volt version. Now, in the instance of the 9-volt version, it's wired to 5 robotics TXT controllers, and because of this, because of the way they're daisy-chained together, it's going to require 3 120-volt power adapters. Now, as always with the 24-volt version, it's going to require that the end user provide all PLCs, all programming, and any other hardware, wiring, power sources, etc. Again, each station of the 24-volt version has a relay board for motor polarity reversal, and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the two factory simulations that we just looked at, the 24 or the 9-volt versions, who might want to transport the model or protect it when not in use. This travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion of the case is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and remain fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of approximately 53 pounds, and this is again without the model inside it. So if you put a model in here, you're basically talking about 100 pounds altogether. And please note that even when using the travel case, these models will still need to be shipped flat. So you always want to ship it flat, not, even though we have the travel cases standing up in the image here, they should be laying flat. Anyway, moving right along, the next model we're going to look at is a basic conveyor belt. And this is a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyor belts can easily be connected to increase the length of transport as you may desire. Components on this model include an excess motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. Dimensions for the model are approximately 14 by 10 by 4 inches, and it has a weight of under 2 pounds. And as before, the standard 24-volt variation includes a multi-pin connector, but in this case, it's 26 pins with a 2.54 millimeter grid, as seen here in this photo. And for a limited time, we do have a 9-volt version pre-wired to the robotics TXT controllers shown here, and one 120-volt power adapter is required for operation. The next model is a variation of the conveyor belt, which includes a punching machine. This features essentially the same conveyor as we just looked at, except this time with the machining station built onto it. Components on this model include 2 excess motors, 2 push-button limit switches, 2 photo transistors, and 2 LED light barriers. Dimensions for the model are approximately 15 by 12 by 7.5 inches, and it has a weight of about 3.5 pounds. Again, this is available in the standard 24-volt variation with the 26-pin connector and 2.54 millimeter grid, as shown in this photo. And for a limited time, we do have the 9-volt version wired to the robotics TXT controller, which requires one 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. And this model, as you see, features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts, as I just mentioned, 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions for the model are approximately 19 by 18 by 11 inches, and it has a weight of just about 8 pounds. Again, it's available in the standard 24-volt version with a 26-pin connector and 2.54 millimeter grid for use with PLC, and also in a limited release 9-volt version wired to the pre-programmed robotics TXT controller and requiring one 120-volt power adapter. Actually, this is wired to 2 TXT controllers, as we see here. Next up is a variation on the idea of a pick-and-place robot, or the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or back 90 millimeters. Axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions for the model are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. Again, it comes in either a 24-volt version with the 26-pin connector and 2.54 millimeter grid, designed again for use with PLC and programming of your choice, or in the 9-volt version, which in this case is not a limited availability model. It is a standard version that's available 9-volt. And once again, it comes pre-wired to a pre-programmed TXT controller and requires one 120-volt power adapter for use. And that concludes our look at the first 9 variations of simulation models. Now, the next pair of simulation models focuses specifically on the area of IoT and are designed for demonstrating and teaching about cloud-based monitoring and control. These models go by the name of Training Factory Industry 4.0, and these are available both in the 9-volt, or excuse me, the 24-volt version for use with PLC and 9-volt variations for classroom and demonstration purposes. They've been designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a larger scale. Now, as the following video showcasing the 24-volt version provides a nicely narrated overview of how the factory works, I'm going to step back for just a moment and allow you to watch and listen to the narrator. The following topics can be addressed with the fischertechnik Training Factory Industry 4.0. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production and lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features not found in the models we previously discussed, besides just most notably the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, which enable the positions of each piece in the work cycle to be mapped. And the use of MQTT, message queuing telemetry transport, that allows the network TXT controllers to communicate with one another. Now, as there are two variations of this model, let's go over what makes them different aside from the voltage requirements. We're going to begin by focusing on the 24-volt version and what makes it unique. First, it is again a bit of a hybrid in that while requiring a PLC for operation and control, it does also incorporate one fischertechnik robotics TXT controller. The TXT controller in this case again serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node Red. This allows the option for not only presenting and using data on a dashboard in the fischertechnik cloud, but also to be able to display data and calibrate the stations of the factory in a Node Red dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, also known as pulse width modulation. They also have push-pull output stages for phototransistors and for buttons. Finally, one of the most important new features. Unlike any of the previous 24-volt models we've discussed, the new 24-volt Training Factory Industry 4.0 also includes access to a sample program. The program in this case is in structured text format and was created based upon a Siemens S7 1500 PLC, and this software is available for download on GitHub. Now, of course, the new Training Factory can also be controlled using other PLC models and other PLC brands once the end user makes some basic adjustments to the sample program. Now, there are source codes that are available for all of this, and this is all available again from GitHub. Now, as with the first of the 24-volt models we've looked at today, each of the workstations of the 24-volt variation of the Training Factory Industry 4.0 model have a relay board for motor polarity reversal and both the multi-pin connector, again 34 pins with a grid of 2.54 millimeters, along with PCB terminals with pushing connections for all inputs and outputs. Now, all of this information and more is available in the 152-page PDF manual, which you should be able to download from the Fischertechnik website or from the Studica website. If you can't get it for whatever reason, because we're making some changes to our website, you can email me and I'll give you that information later, and I'll be happy to send that to you. In the case of the 9-volt version, the control is facilitated through use of 6 robotics TXT controllers. Now, unlike all other 9-volt versions we've looked at previously today, as you heard in the presentation, these are programmed not using RoboPro, but instead using C, C++. Again, all programming is preloaded with the 9-volt version so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF for this model, which again should be available on our website, but if you need it, you can contact me, I'll get through that. You should be able to get started quickly once you get those set up. The 9-volt version will require the addition of 3 120-volt power adapters. Of course, it requires the ability to access the internet. That goes without saying for each of these. You need to be able to access the internet to get to the cloud-based dashboards, as well as a tablet or some sort of device for accessing that cloud-based dashboard. Now, dimensions for these models are approximately 39 by 31 by 16 inches, and they have a weight of approximately 51 to 53 pounds, again, depending on which version we're talking about. And as with the 2 factory simulation models that we looked at a little bit earlier, we again recommend the optional travel case to help protect your model during transport or storage. And that is the Training Factory Industry 4.0 model, again available in both 9-volt and 24-volt variations. Of course, you might well be wondering how much any of these models cost. So let's take a real quick review of each option I've discussed, along with the pricing for each. First up, the vacuum gripper robot in the 24-volt version, you're looking at a cost of $974 per. In the 9-volt version, again with the TXT controller, you're looking at $1,199 per unit. The automated high bay warehouse, the 24-volt version is $1,099. The 9-volt version with the TXT controller is $1,319. The multi-processing station with oven in the 24-volt variation for use with PLC is $999. The 9-volt version with the TXT controller is $1,479. Sorting line with color detection, 24-volt version is $836. The 9-volt version is $1,129. The full factory simulation model, which again puts those 4 models together into a unified work cycle, the 24-volt version requiring the PLC and the programming, you have to provide both of those, $4,029, and the 9-volt version, you're looking at $5,239. The conveyor belt, 24-volt version, requiring PLC is $226. The 9-volt version with the TXT controller pre-wired, pre-programmed is $519. The punching machine with the conveyor belt in the 24-volt version, again requiring PLC, is $299 per unit. The 9-volt version with the pre-programmed TXT controller is $599. The 3D robot in the 24-volt version for PLC, $865. In the 9-volt version, $1,169. The indexed line with 2 machining stations in the 24-volt version, $869. In the 9-volt version, $1,399. And finally, the Training Factory Industry 4.0s in the 24-volt version. Once again, this will require PLCs, but it comes with that access to the program, the sample program. These are $7,896 per unit. The 9-volt version, which of course comes pre-wired to the TXT controllers and is pre-programmed using C, C++, is $7,560. And other items that I've touched upon during the presentation, those 120-volt power adapters that I keep mentioning for the 9-volt models, they are available for $12.99 per unit. And the travel and storage case, which again is designed specifically for the factory simulation and Training Factory Industry 4.0 models, the 9-volt or the 24-volt variations, these are $1,000 each. So on that note, if you have any questions, this would be the time to use your question and answer window, which you will find on the Zoom or the Zoom toolbar. You could use the chat window that should be up there. That should be right up there. There's a little icon. You can type in either of those. And if you have any questions, while you're doing that, I will show you what the next steps are that you can take. If you would like to request a full color brochure and current pricing, quotes, what have you. If you'd like to ask any questions directly, again, receiving a quote. If you'd like to speak with your dedicated educational representative, if you'd like to do any of these things, you can call us directly. Our phone number here in the US is Studica. It's 888-561-7521. You can email us for any general questions, info@studica.com. So this is whether you have a question on models, availability, need a quote, what have you, you can just info us or email us there at the info@studica.com. If you do have any questions for me specifically, anything that I talked about today, anything that I didn't talk about, some of the brochures and things that I mentioned, if you needed a copy of the brochure, if you needed a copy of one of those manuals that I was talking about, if you'd like to look those over, you can email me directly. My email address, again, is lance.zurek, lance.zurek @studica.com. So as I see no questions popping up, I will go right to the next window and say thank you for attending today's presentation. We're very happy that you could make the time to attend, and I look forward to hearing from you soon. So take care.